The code powering your phone and your digital life traces back to a single mind in the ancient world. He is the father of algebra, and the word algorithm itself is a translation of his name. That name was the brilliant scholar Muhammad ibn Musa Al-Khwarizmi. Despite his influence on modern computing, his early years are largely unrecorded. He left behind no royal titles, no inheritance of family wealth, and no records of his lineage. To understand how he developed the concepts that govern our modern world, we have to look past the lack of a recorded pedigree and focus instead on his specific geography. Al-Khwarizmi was born around 780 CE in Khwarazm, a region located in what is now Uzbekistan and Turkmenistan. As this image shows, the local environment was defined by a massive river system cutting through a harsh, arid desert. It was a life-sustaining oasis in a region where water dictated survival. Because this water system provided the only reliable route for hundreds of miles, it naturally funneled travelers, merchants, and scholars into a single dense hub. Khwarazm functioned as a metropolitan crossroad where the architectural scale of its mud brick walls and turquoise domes anchored a trade network linking Persia, Central Asia, and the Islamic world. Within these walls, the economy moved on a massive scale as traders negotiated over silk, weighed spices, and exchanged precious metals. While this wealth circulated around him, Al-Khwarizmi likely grew up in a respectable middle-class household, lacking the resources of the ruling elite. However, in a community where trade relied on precise measurement and record-keeping, education was prioritized as the primary path to social and professional advancement. The merchants traveling the Silk Road traded more than physical goods. They also carried books, astronomical tables, and mathematical theorems. Three distinct traditions converged in Khwarazm: mathematical tables from India, geometric principles from Greece, and astronomical observations from Persia. This influx of information was accelerated by the Abbasid translation movement, which systematically converted these disparate foreign texts into Arabic. This manuscript page displays the result of that academic blending, showing hand-drawn geometric shapes meticulously analyzed in Arabic text. Al-Khwarizmi studied these translated traditions, absorbing various methods for calculating land area, inheritance, and architectural dimensions. His training also extended to the physical tools of observation. The intricate engravings on this brass astrolabe show the level of mathematical precision required for navigation and timekeeping. By the time he reached adulthood, Al-Khwarizmi was positioned at the meeting point of the medieval world's most significant intellectual streams. Trained in these cross-cultural methods, Al-Khwarizmi chose to leave his homeland to apply his knowledge on a broader scale. He joined a massive caravan for the trek across the sun-drenched desert landscape, separating Central Asia from Mesopotamia. He traveled toward Baghdad, the imperial capital, because it was the only city with the libraries and translation centers capable of utilizing his specialized education. Upon his arrival, he was appointed to the House of Wisdom, the empire's premier research institution. Because he had spent years reconciling Indian calculation methods with Persian astronomy and Khwarazm, he possessed the exact technical skills Baghdad needed to organize and advance its growing scientific library. He developed algebra by merging the logical rigor of Greek geometry with the efficient decimal-based calculation methods used in India. This systematic method of solving equations eventually reached Europe, where his name was Latinized into the word algorithm. These foundations of the modern world were built because a student grew up in an oasis where the most disparate ideas of the ancient world were forced to meet.